Hello friends, welcome back. In the previous tutorial, we have learned how do we create our own libraries and how do we extend them. How inheritance helps us to perform reusable code, reusability and implement reusability and extendability in the code. And you can see that I have deleted the mymathlib project. I also deleted mymathlib DLL file. I completely deleted that folder, my libraries folder. At present you can see that I have a new inheritance demo project which has scenes folder with the current scene, scripts folder with the inheritance demo which has nothing, there is no code inside it, and it is attached to the main camera and open in the MonoDevelop. That's it. And you can see that there is no mymathlib.dll in this one. If you delete the my libraries folder from there, automatically from the references mymathlib will be removed, because automatically system will search for the DLL files and adds. If there is no DLL, then it will remove that one. If you find, then you just delete it. Right click and say delete. Now let's continue. What we do in this tutorial means we are going to understand how code works, how inheritance works, what actually happening behind the scene. Now what I do means I create one class. We understand step by step. Please try to understand. We create a class and the class name is, let's take B. Now B indicates the base class, any base class. So here what I do, I create members, public, float. Let's take the member name is X. Another one public, float. The member name is Y. You can see that I just created two members, X and Y, in the class B. I can create the variable of it, and what I can do means we know that even though we do not write the constructor, implicitly there is a constructor public B, a default constructor which looks something like this, right friends? It looks something like this. I can create the B variable. Here you can see that B, I can create a B1 reference. It points to a new B instance, semicolon. That's it. Now here you people need to understand and remember whatever I am explaining. What I do means I just copy this code from here, explain you in Paint. I expand it, I delete this code, move it a little bit down. Yep. Here we understand how this code works behind the scene. Let us understand step by step. We have a stack and we have heap. Two memory locations or two memories. One is stack, another one is heap. When the start function executes, we know that the start function is going to come and sit or pushed on top of the stack. Then what happens? Control moves inside, it executes the inner statement. First B1 will get executed. We know that the system is going to create a B1 memory on the stack. This is B1 memory and it initializes it to null because it is of class type. Class is a reference type. Then as we have equal to sign, the right hand side part is going to get executed. The new keyword is going to execute first. What new keyword does? It allocates the memory of type B on the heap. So you can see that the B has two members, X and Y. Both are of 4 bytes, so 8 bytes of memory location it allocates on the heap. So you can take this one is X, this one is for Y, and both are initialized to 0. The new keyword will initialize them to 0, and let's take its address is #1, the beginning address of this 8 bytes of memory location. That is what the new keyword does. Then the new keyword invokes the B constructor so that it can initialize members these members if with some other value or a same value. So when it invokes the B constructor, it simply won't invoke the B constructor. We know that it calls the B constructor, passes the address of newly created memory location, that is #1, right? So when it sends the B #1, we know that the control jumps to the B constructor. Now when the control moves to the B constructor, we know that the B constructor is moved on top of the stack. Now B is on top of the stack. And also we know that the B constructor has implicitly one extra parameter which is of type B, this. So B, this is written there, right friends? That means we have one variable of type B and its name is this. And as we are sending #1 is going to store in this variable, and this is of type B. So it starts pointing to this memory block on the heap. Now one of the important thing you need to remember here is B1 is of type B, this is also of type B. Whenever you create a new reference of type B, it can refer or point to a memory block which is of type B. This is actually B instance, right friends? It can refer to that instance which is of 8 bytes. It can only read 8 bytes. That also you should remember. It can only read 8 bytes of data, friends. That reference can read only 8 bytes of memory location. That you should keep in your mind. Understanding? Let us proceed. Then what happens here means, as this is pointing over here, no problem. You should remember here, if you are not writing here, colon base bracket. If you do not write explicitly anything in front of the constructor, there is always implicitly a little bit code written, that is colon base bracket. Now what is that? This is, you can see it is something like a function call, right? Base bracket. Now what is that? Actually it is the call to the superclass constructor. Now base call means call to the base class constructor. It calls the base class constructor, friends. That you should understand. Now when it calls the base class constructor, it sends one parameter, that is this memory location value, that is #1 will be sent to upward. So I can say here this. I can say it sends the current memory location address itself to the upward. It sends this to upward or a superclass constructor. Now one of the things you need to remember here is, we know that every class, if you explicitly do not inherit, it is inherited automatically behind the scene by one class, that is object class, right friends? And the object class looks something like this: a public class object, and it has a public object constructor. It is going to look something like this. There is nothing in the object constructor, but yet still it calls the superclass constructor. So before executing this block, what system does? It calls its base class constructor, friends. So when it calls the base class constructor, we know that the base class constructor object is going to come and sit on top of the stack. Understanding? And you can see that implicitly it is going to have its own extra parameter, this. So here object this. Now important thing you need to understand here, guys, here it is going to have its own variable known as this of type object. You can see that when the control calls the base class constructor, we are sending this. And one of the important thing you can see here, this is of type B. B is a derived class, right? B is a derived class of the base class object. Object is the base class here. B is the derived class. Now this we are sending, it is a derived class reference. It is a derived class of type B reference, right friends? It can point to this memory location. But you can also see that we are sending the derived class reference #1 to the base class reference variable. Base class can point to the derived class, that you should remember that. Base class can point to the derived class safely. We understand step by step, don't worry friends, okay? At present you remember that you can send the derived class reference and store that or assign to the base class reference. So here it is going to have #1 inside it, and it also starts pointing to that memory block. Good. That is what happens. There is no more base call. Here there is no base call, friends. Why? Because object is the root of the hierarchy. So once it goes up to here, the control, if there is anything inside this block, it will execute. Actually there is nothing in this object class constructor. Control will just come back. And when the control comes back, we know that object constructor is not going to be available on the stack. Okay, now the control came back. Once the control comes back, what it does, it executes this inner part, inner code. So there is nothing at present here also. So the control will just come back. Now when the control comes back, what happens means the B constructor is also going to be removed from the stack, right? Then what happens? We know that the new keyword is going to return the address of the newly created memory location #1 and puts in B1. Here what happens? The B1 is going to have now #1. Then what happens? It starts pointing to this memory block. So here we have understood few little implicit things, that when you say BB1 new B, it sends the #1 there upward. It calls the base class constructor. Before executing the base class constructor code, here B class constructor code, not base class. Yeah, this base class constructor B code, it goes to its base class constructor. It calls implicitly, there is a colon base in front of this B constructor. And it goes to the superclass constructor, that is the object itself. It executes there, if anything is there, and then the control comes back. After coming back here, the control executes this block, the inner block. After executing that, the control comes back to this place. That you should remember. I can show you if you want. What I can do means a right click, go to declaration. I just want to show you that there is an object class in the system namespace, and that object class has the constructor public object bracket. That is what I have written here also. You can see that public object just bracket, right? Implicitly we have object this. That is the object class, friends. It will come up to here and comes back. And one of the important thing you need to remember is you can ignore this part of execution. While understanding or executing the code, actually we won't see this part. We can ignore this part. We need not to understand that there is a base class call in this B at present. We can ignore that. But it's okay. If you understood this much, whatever I have explained, you can continue. There is no problem in this. This is the current status, guys. Now here you need to remember that B1 is of type B, so it can read, the total size of the B is 8 bytes, so it can read only 8 bytes of memory. It can point to only 8 bytes of memory. That's it. Let's proceed. Now what I do in the next step, I am going to create another class, and that is going to be D. Now D is going to derive from the B class. Now this time you can see that this base class B is going to become the base class for the derived class D. Opening brace, closing brace. You can see that D is extending from B. Now what I do, I create one public member, float Z. I have added one memory, just Z. Then what I do, I create an implicit constructor, that is a default constructor, parameterless constructor D. That's it. Then what I do, here I create D, D1 is equal to new D. Save it. Now we know that we are going to create a derived class variable D1 in this code. And let me explain how this code is working. I copy this code from here, come to the paint, understand guys, step by step you will get clear idea. Okay, what I do now, I create a stack again. Here we have a stack, or I can say here, till here we know already. B1 equal to new B, what happens we know already. How the code executes we know that. So what I can do means I can just take the current status of the stack and the heap from here. I copy that and paste it in this file. We know that this is what happens when this line will get executed. So let us proceed and get what happens when D1 equal to new D will get executed. First D1 will get executed. So what system does? It creates one memory location for D1. It creates one memory location for D1 and puts the value null inside it. That is what happens when D1 will get executed. Then right hand side part is going to get executed. First new keyword is going to get executed. What new keyword does? You should understand this part. When the new keyword executes, it creates the memory locations for the inherited members X and Y as well as the D class its own member Z. That means total 12 bytes, 4 plus 4 plus 4, total 12 bytes of memory location will be allocated, friends. So here you can see that it creates another memory block. Let us take this one is for X, this one is for Y, and this one is for Z. All the memories are initialized by 0 by the new keyword. It initializes all the memories to 0. Now one of the important thing you need to remember here is this memory block, the X and Y memory block that you see here. This block is coming from the base class, friends. This is from the base class. X, Y are coming from base class. So what system treats these things are coming from the base X and Y. Understanding? Now this complete memory block is going to have some beginning address. Let's take the beginning address is #9. That is the address of the whole memory block. This complete memory block. And this #9 is the address of this complete memory block. Let us proceed. Then what happens? The new keyword is going to call the D constructor. Now when D constructor will get called, it is not going to simply call the D constructor, right? It calls the D constructor, passes the address of newly created memory location #9. Now that #9 will be sent to the derived class D constructor. Now when the control comes to this place, we know that it is going to have its own one extra parameter D this. And you can see this is of type D. Understanding? Now here on the stack, D constructor is going to be pushed and it is going to have one memory location with the name this. And it is going to hold #9 that we are sending. Once we store the address in any reference type, it starts pointing to that memory block. And this is of type D, friends. This one is B type, right? B instance. This is a D instance complete. Now after that what happens? Before executing this, we always remember that. We need to remember that. We know that here implicitly there is a statement return base this. Implicitly it is calling the base class constructor and passing the this itself. So here what happens, friends? Before executing this, the control moves to its base class constructor. Its base class constructor is the B constructor, friends. Right? You can see the base class is B. It is not object. Explicitly we are telling that D is inheriting from the B. So B is base class of D. So control jumps to the B constructor. Now what happens here? This time B constructor is going to be moved on top of the stack. B constructor is moved on top of the stack, and we know that it is going to have its own implicit variable B this. You can see this time this is of type B of superclass. Here we are sending this is of type D, which is a derived class reference. We can store the derived class reference or assign to the base class reference so that the base class reference can start pointing to the derived class. Safely it works, friends. Remember this. So here it creates another memory location with the name this, and that is going to be assigned by #9. And what happens here? This is going to start pointing to this memory block #9. Okay, we are at this place. Then we know that before executing this block, there is an implicit code written here in front of the constructor, that is base this. Implicitly it is calling the base class constructor, sending the value or the reference of itself, this reference. So #9 will be sent from here. So there is an object class, we know that, right? There is a public class object, and it has a public object this, opening brace, closing brace, right? Implicitly we have this one. So what happens here? It calls the base class constructor. Object is going to be moved on top of the stack. Object constructor is going to be moved on top of the stack. There is now object constructor at top of the stack, and there is this variable available inside it, and it takes #9 there, and it starts pointing to this memory block. Then you can see that there is nothing in the code block, the constructor's body, just control comes back. When the control comes back, we should remember that the object constructor is not available on the stack. No more pointing here. Then what happens? It executes this block or this B constructor body. There is nothing inside it, so control just comes back. Once the control comes back, we are not going to have the B constructor there. Good. Then what happens? The D constructor body will be executed. There is nothing inside it. Control will just come back. So what happens here? D constructor is also going to be removed. Right? Then what happens? Once the control comes back over here, the new keyword is going to return the address #9. So #9 will get stored in D1 memory location. #9 is stored in D1 memory location, and D1 starts pointing to this memory block. And one of the important thing you need to remember here is D1 is of type D. It can read 12 bytes of memory location. It can point to the derived class memory block of 12 bytes, and the base class B1 can point to the base class instance of 8 bytes. Understand this thing. This is how actually the code works, friends. This is how the code executes behind the scene. Remember that every class, before executing its own constructor body, it calls the base class constructor first. Remember that. That is also known as constructor chaining in object-oriented programming. So in the next tutorial, what we do means we write some code in the D constructor and the B constructor and see that whether it is going to one constructor to another constructor and coming back, initializing these members, and we see, yes, actually there is something called as a base members. We see that, and also we see that there is implicitly a base call available there. So thank you guys, thank you very much. Watch this video again and again, understand each and every step that I have explained, practice. So for this tutorial, I think this much is enough. Keep learning, keep coding, keep sharing. See you in the next tutorial.